All right. So we're going to work on standard deviation and variance today. Now, both of these things, and I'm just going to kind of write this up here, they measure the spread of your data. Like how spread out is the data from each other. So measures of spread. We've been working on measures of central tendency, mean, median, mode, that kind of stuff. So measures of spread, how far out the data is from itself, really. Okay, now a deviation is the key to calculating standard deviation and variance both. So a deviation, it's literally just the difference, so we're going to do subtraction, between a data value and whatever the mean is for the data set, or the average, if you want to look at it that way. Okay, now data value and the mean. You need both of those. You're going to see the symbols down here, but basically what you're going to do is you're going to take a data value and subtract the mean, and that will give you a deviation. How does it deviate from the mean? How is it different from the mean? It's always subtraction. Sometimes that could be a negative number, and we're going to talk about that in a second. And in this lovely formula here, the data value is represented with x, and the mean is represented with that x bar I've been telling you about the last couple of days. So the data value minus the mean, that's what's going on in the formula that you see right here on the top of this fraction. So it's not a big deal. Other symbols on here, this weird looking E is called a sigma. Does anybody know, like mathematically, that's an operator, does anybody know what that symbol would mean for math? Like it's a sigma is the name of the letter, but does anybody know what it means, like you're supposed to do? Pi is a different Greek letter, but what about... I don't know, you guys may have seen this in the science. Somebody knew last period, so I just didn't know if anybody would know it here. I know Nathan knows, he's dying to tell you. Okay, no, this just means find the sum. So you're just gonna add together all the deviations is what that means. So when you see this on the top of this lovely fraction here, it means find the sum of the deviations. And then we're gonna divide that by n, and n is just the number of values in your data set. And in that, it's literally an average. So if I give you a list of 10 numbers, the n value would be 10. So it's just the number of values in your data set. So the variance, really what it is, this is just an average. It's the sum of the squared... Oh my gosh, I just spelled squared wrong, forgive me. The squared deviations. I forgot the E, but I tried to put it in there and it looks worse than it did before. Okay, sum of the squared deviations divided by n is the number of data values. So it's just going to be an average. And what we're going to do, we're going to find the deviation, we're going to square it. I'm going to explain that to you in 1 second. And did I forget any? Oh yeah, sorry. The other symbol in there, it looks like an O, like almost like a cursive O. This is actually also a sigma, but in the Greek alphabet, this is the lowercase version, where the E looking thing, that is the uppercase version of a sigma. And the symbol there, you see that squared is the variance. And then the standard deviation is just that lowercase sigma. So to find the standard deviation, it's just the square root of the variance. Okay, in general, all right, the greater your standard deviation is, the bigger that number is, the more spread out the data is. And we're going to talk about how far spread out and things like that as we get into some of these examples. So the bigger the standard deviation, the more spread out. Okay, now, let's scooch this up. So we're going to do this one by hand. And you do not have to write these in a particular order, but just to make this a little better visually, here's what I'm going to do. These are some test scores, and I'm just going to write them out vertically just really quick. You don't have to write them in a particular order. So I have an 89, a 79, 74, 67, 99, 91, 84, and 81. So we're going to calculate how these deviate from the mean. All right, so deviation is just going to be, for our example here, it's just going to be your test score minus the mean. All right, so we got to find the mean first. So I'm just going to grab my calculator here real quick. I'm just going to add these guys up. I got all these test scores, 89, 79, 74. I'm just adding them up. 67, 99, 91, 84, 81. Okay, I added all these guys up. If you do that, I got 664. How many test scores I got here? 8. So I'm going to divide that by 8, and that's going to give me 83. So the mean here, we need that to be able to calculate these deviations. The mean is going to be 83. Okay, now all you're going to do to calculate a deviation, you're just going to take your test score, whatever it is, and we're just going to subtract the mean. And sometimes that number's negative. That's completely fine. So like my deviation for that test score of 89, just do 89 minus 83, so that would just be 6. So the deviation would be 6 from the mean there. And just the test score. So I'm just going to take, it's the data value minus the mean. So the second person's test score is a 79. So subtract the 83. Now, that's actually negative, right? That's okay. It still means it's 4 spots away from the mean. It's just 4 spots in the negative direction. Just to do it everyone, and they're not going to be bad numbers or anything like that. So if I do, let's see, 74 minus, why is my brain not functioning? Is that negative 9? All right, 67, oh man, negative 16, 99. Just each one, I'm just subtracting the mean from the test score to figure out how far away it is. That's positive 16. 91 minus 83 is going to be 8. This is just how far away the test score is from the mean. 84 minus 83, they're just 1 spot away. And then 81 minus 83 is negative 2. Okay, now when you calculate the deviation, it's just how far the number is away from the mean. And you'll see I got some negative values there. So to take care of the negative, what they do when they calculate the variance, which is what we're going to do here first, you are going to square the deviation. So I'm just going to abbreviate that. I'm just going to square the deviation. If you guys want to look, I'm going to pull this down real quick here. In the actual formula that they have for this x minus x bar squared, that's what I'm doing right here, is I'm going to square the deviation. So each one of these is a deviation, and it's just going to make everything positive, because when I square, like if I do negative 4 times negative 4, that becomes positive 16. Okay, so I'm just going to write these deviations squared down. So 6 would turn into 36, negative 4 would turn into 16, negative 9 would be positive 81. You guys may or may not know 16 squared, but 16 and negative 16, both of those squared, 256. Oh my goodness, I can't write. 256. 8 squared, 64. 1 squared, don't put 2, it's just 1. And negative 2 squared is 4. Okay, to calculate the variance, you take the sum of the deviations squared. So all we're going to do here is add these. I'm just going to add those numbers, the 36, the 16, 81, 256 twice, 64, 1, and 4. Should get 714. I'm not on the screen. Okay, so I'm adding those up, and then you divide by how many there are. There's still 8 of them. And the variance is the average of the squared deviation. So I'm going to divide that by 8 real quick. And sometimes these are nice numbers, sometimes they're not. It's okay if it's not. I got 89.25 here. Okay, now all you have to do to get the standard deviation is just the square root of the variance. So after we did all that work to calculate that 89.25, we're just going to take the square root, And I'm just going to round 2 decimal places. Almost always these numbers are not, oh, what did I do? Not nice numbers. So just go 2 decimal places. That should be good. So I'm going to say my standard deviation 9.45 from the mean. Does anybody have any question? We're going to talk more about how to actually analyze this on the back. Okay. Now, little different display of my data here. I have 2 dot plots. And on the left you have the heights in inches of a team for the Pacers and the Lakers. This is not the current team. These are a little outdated. But these are the heights on a dot plot. So the way you read these, each dot represents a person. None of these are nasty numbers or anything like that. So I'm just going to write down the heights of each person real quick vertically so I can have that. So each dot represents a person. And you don't have to do these from least to greatest, but I'm going to do this. If you're looking at your dot plot, you have 1 dot for a person and their height 69 inches. So that would be what? 5'9". All right. And then here, let me pull this down so you can kind of see it just a little bit. I should put these closer together. Then I have 2 people, 2 dots, both on the 70, so that's 2 people that are 70 inches tall. Then you got nobody for the 71, so I've got 1 person for 72, 1 person for 73, 1 person for 74, and then I got nobody for 75 or 76. I've got 1 person for 77, 2 people on 78, and 1 person on 79. I'm just going to have to scooch this up so you can see. So 2 people on 78 and 1 person on 79. Okay, we're not going to do this by hand here. I'm going to show you how to use the calculator to do what we just did. Okay, so these are all the heights. How many people do we have? 10 people. Okay, so these are 10 players. Okay, what I'm going to have you guys do, what we did yesterday, if you can get to the menu where we did mean, median, and mode, it's going to literally be the same thing. We're just going to look at a different place on that stat screen. So if you want to hit on your calculator, just hit, or you could do it by hand if you don't have one, or if you want to, but I'm going to have the calculator do this for me. So hit stat, and you should go to the edit menu because we're going to type these heights in. Okay, now you guys probably have data from yesterday, so if you do, if you arrow up to the top so that the list 1, the L1 is highlighted, don't hit delete, that'll delete the column. You want to hit the clear button, which is under the arrow keys here, and then hit enter. And that'll wipe the whole column out so you can start over and put new data in. So just arrow up to the top, hit clear, hit enter, and then that should put you back in there. Did anybody accidentally delete their, okay, if you accidentally delete, no big deal, just hit stat. And then the 5th thing on that menu says set up editor, and just hit enter twice, it'll say done. And now if you go back into that menu and to the edit, it should restore that column. So if you ever accidentally delete the column out, just hit stat, set up editor, and that just resets it. And it doesn't actually, it won't wipe out the data. So if you accidentally deleted a list, it'll actually retain that list in there for you. It's just if you accidentally delete a column. Okay, anywho. So stat edit, and I'm going to type in these heights. And I always just kind of, as I get done or whatever, I'll go back and check and make sure, because last period I mistyped something. So just look at your data real quick. There's not that many of them. There's 10. So just make sure the numbers look good. Should have 10 of them. And once you got those heights typed in, it's the same stuff same menu from yesterday. Just hit stat. And then we're going to arrow over to that calculate menu, that same 1 variable statistics, that very first one, just hit enter. People's screens might be different here. You want list 1 if you have this screen because that's where we typed our data. And just keep hitting enter till it shows up. Okay, now, useful information from that page that I'm going to jot down real quick. The mean height there is 74. That's that X bar. That stands for the mean. And you guys see the sigma in here? None of these are really useful for us right at the moment. That first one, the sigma x, that just means that's the sum of all the data values. And the sigma x squared means they took all these heights, added them, or they squared all of them and added them together. That's not part of what we're looking at today. So those two aren't going to be anything to you. You're looking for the little sigma x. Okay, now on the calculator, that is going to be your standard deviation. Now, I'm just going to go ahead and round that to 2 decimal places. So I've got this like 3.577, blah, blah, blah. So I'm just going to go 3.58 here. That is my standard deviation. Now, nowhere on that menu does it display the variance. So if a question asks you for the variance, really you just find the variance to get the standard deviation is really what it's used for. But if a question asked you for the variance, and you knew the standard deviation. Okay, I don't know the variance, but I do know the standard deviation. How would I find the variance if I knew the standard deviation? You just square it. So the variance is the standard deviation squared. If you have the variance, you take the square root to get the standard deviation, so if we're working backwards. So if a question asks you for that, I'm just going to do like 3.58 squared to get my standard deviation. And again, I'm going to take my standard deviation and square it. And I'm just going to go 2 decimal places there, so about 12.82 if the question asked you for that. Okay, now we're going to attempt to do this for the Lakers also. So like let's write these guys' heights down, and you'll see, let's see, you've got a ton of people on that data set. If you're looking at it, a ton of people have the same height. There's 6 different dots on the 74 inches. So you should have 74 6 times here. And then I got one person 75 and one person 79 from that data set. And again, if you don't have a calculator, you can calculate this by hand. Find the mean and then find the deviations, square them, and then take the average of that. That'll be the variance, and take the square root to get the standard deviation. If you do have a calculator, though, I might suggest that just because it might make it a little bit faster to do. So just remember, when you're trying to get rid of the data, hit the clear button and hit enter, and that'll wipe out all the data in that column. And this team also should have 10 players on it. And 6 people have the same height here. If you get those typed in, just to get to the statistics, just stat, calc, and that very first option, one variable statistics. And I'm just going to write down the mean here. Actually has the same mean as the Pacers, but this definitely has different standard deviation. So that standard deviation on that screen is that sigma x. So I'm going to say about 2.28. The variance is not displayed on the screen for the calculator. It just doesn't write it down, but you can get it real quick. Just take your standard deviation, that 2.28, and square it. That'll be your variance if you got a question that asks you for that. So I'd say about 5.2 there. Okay, now here's what we're going to use this for. These questions, and actually let me back this up one second. If you guys look at this, the Pacers' standard deviation is 3.58 compared to the Lakers, which is 2.28 here. If you guys come back and look at this dot plot, what this is saying, the bigger the number is, the more spread out the data is. If you look up here, these dots are way more spread out than these. These are more concentrated in the same area. So the bigger the standard deviation, the more spread out your data is going to be. So we're going to ask you in a question like we have down here. It says the heights of all the Pacers fall within how many standard deviations of the mean. So this is just going to be a nice whole number. It's going to be like 1, 2, 3, 4, 5, something like that. What you want to do to figure out how many standard deviations you are away from the mean is I'm literally just going to put the mean in the very middle of this paper, in this space. Okay, to calculate one standard deviation, what you're going to do is you are going to add whatever your standard deviation value was, and I'm going to subtract also whatever my standard deviation value was. So, oh, sorry, I'm throwing things. Okay, so I'm going to add. So I'm going to do Why am I getting my calculator for that? Okay, so if I add 3.58, this would be 77.58. On the other end, though, I got to also subtract that from the mean. So I'm going to do 74 minus 3.58. So on this end, I'd have 70.42. Okay, now what that means is anybody's height that falls between these two numbers is in 1 standard deviation. They're within 1 standard deviation of the mean. Okay, do I cover everybody on the team's heights between those two numbers? No, we're not. Like there was somebody that was 79, so it's not big enough. Okay, so I got to go out another one at least. Okay, so to do that, we're just gonna same thing. I'm gonna add 3.58, but add it to the number you just got. On the left, you're gonna subtract that standard deviation, and that will take you one more deviation out. You got to add it and subtract it on either side. That is one away. So if I do the 77.58, and I'm going to add the 3.58. Oops. This one would be 81.16. On the lower end, you're going to take that 70.42 minus the standard deviation 3.58 that we got. This would be 66.84. Okay, now what that means is anybody between those two heights, all right, now I'm within 2 standard deviations of the mean. Okay, does that cover everybody's height on the Pacers team? Yes, okay, everybody falls within 2 standard deviations of the mean, so that's what I would write as my answer right there. They all fall within 2. Okay, now we're going to do this for the Lakers. They ended up with exactly the same mean, the 74, but their standard deviation was 2.28. All right, so I'm going to add 2.28 and I'm going to subtract 2.28. That'll get me within 1 standard deviation of that mean. All right, so on this end, I'm going to have 76.28, and then on the lower end, we're going to have 71.72. All right, so anybody's height between those two numbers is within 1 standard deviation of the mean. And that's definitely not going to cover everybody. So I got to go out again. All right, so to do that, to go one more, whoops, I'm going to go 2.28, just add it on one end, subtract it on the other. Okay, on the upper end, that would take you to 78.56. And then on the lower end, I'm going to do that 71.72 minus 2.28. This would be 69.44. And I know somebody was 79 inches. I remember writing that down. So we're not covered here. So here I'm within 2, but that doesn't cover everybody. So we got to go out again. All right, so just going to leave this on this end. I'm going to subtract the 2.28. This puts me at 67.16. And 78.56 plus 2.28 is going to give you 80.84. All right, so I had to go out for the Lakers. I had to go out 3 standard deviations to cover everybody's height. Now, what that would also tell me, if we were looking back at the data here, if I look at the top on these dot plots, okay, here's what I would tell you. These two guys, the 169 and the 179, those would be outliers in that data set because I had to go out 3 standard deviations from the mean to get that. Whereas the Pacers, they would not have any outliers at all because their data is pretty spread as it is. Whereas the Lakers, it's pretty concentrated in that middle area. So that's why I had to go out so many standard deviations. So that would maybe visually allow me to see some outliers like we were talking about yesterday. Okay, is anybody having a question about the standard deviation or how to find it or anything like that? Okay, now you guys all